So here in section 2.2, we're going to look at graphical methods for describing quantitative data, so numerical data here. So in this first example, we want to look at honey as a cough remedy. So here we're testing honey against dextromethorphan, so that's the medication that's in Robitussin and many other cough suppressants, and then a control group, which is just placebo or some innocuous medication. And these are cough improvement scores. So now, while this is on the surface numerical data, it's really a Likert score. But we're going to, since it is given as numbers here that are ranked, at least it's ranked categories, we can use some quantitative displays for this. So we have some data scores for each one. Notice we've got different number of values for each. One way we could analyze this data is by constructing a dot plot for the data. So a dot plot is just a bar graph with dots as columns. So instead of using the height of the bar as a solid bar, you're using number of dots. So this is the dot plot for this data. So you've got the improvement score here, and then over here, this is frequency on the vertical. So for example, the frequency of this value, which is the value 1, is 3. So there's 3 ones out of all of the data. So this is an aggregation of the data in one dot plot. So we can look at this data, and how did we plot this? Well, we took the 14, and 14 would be right here. We did one dot right there. 11, we did a dot here, another 11. Then we stacked up that dot. So as you get repeated values, you stack your dots. So we went through all of the data that way. That's how we generated this plot. So what we can see here is that this data, it's not symmetric here. It almost looks like it's, it's got two peaks here. It's not quite bimodal, but we definitely have two peaks in the data. Two areas of concentration. So that's unusual. Now let's look at the individual data values here. So if we look at the honey group versus DM versus control, so if we do a dot plot for honey here and dextromethorphan here and then control here, so that's improvement score, and then I've got them labeled control, DM, and H for honey. And then looking at those dot plots, we want to try and interpret and compare these groups. So when I say interpret, here's a good acronym for you. SOSS, C-O-S-S. So interpret, give me the sauce. What is the center? What are the outliers? What is the symmetry? And what is the spread of the data? So first of all, the center of the data. So, well, we haven't talked formally about what we mean by center, but we could try to find sort of the middle value where there's the same amount below as above. So for the honey values, you would expect the middle maybe to be, I don't know, approximately right here. So let's see, we got 3, 6, 9, 10, 11, 12 above this. 1, 2, 3, 4, 5, 6, 7, 8, 9 below. So maybe your center is more like right here. And then for the dextromethorphan data, let's see, it looks like it's around this column. I'm just estimating here. I see 1, 2, 3, 4, 5, 6, 7, 8 dots. 1, 2, 3, 4, 5, 6, 7 dots. So probably about right there. And then the center for this bottom data, the control, looks like it may be right there around, what is that, 7? Because we have 3, 4, 5, 6, 7 above. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 below. So maybe that's a little bit high. So maybe about right there. But we get a pretty good idea that the center for honey is higher than the center for dextromethorphan is higher than control. So center at least looks like the center for honey is higher than it is for dextromethorphan, which is higher than control. Outliers. Outliers are data values that are far away from the rest of the data. Usually gaps in the data will tell you about possible outliers. So here we do have a gap of one value and a gap of one value, and then these values are next to each other. So I would say, probably not any outliers here. Now here we've got, again, this is a gap of just one value. Okay, and then you've got three values that are together. Here there's no gaps in between. Gap of one value there, gap of one there, gap of one there. These guys out here, these might be possible outliers. We'll talk a little bit later in the course about how to find outliers, how to categorize them. So sometimes it's obvious. In this data, there's really not any real obvious outliers. So for outliers, you want to look for gaps in the data. And outliers are data far from the rest. They don't fit the normal pattern. Symmetry, what's the distribution of the data? So if I try to draw a smooth curve across the top here, that's not really quite what I wanted to do. Something like this. We can see that this is not a mound shape or a bell-shaped curve. It trails off to the left, so this tail is stretched out to the left. We call this skewed left. Now this one, well, this is almost symmetric here. I think if if this value was right here, these would look, pretty close to the same thing. So this one I could say approximately symmetric. And then this one, yeah, this one is fairly symmetric too. This one's approximately symmetric. That's probably the most symmetric. This one is maybe very slightly skewed to the left. This is definitely skewed to the left. So the tail goes to the left. If that tail trailed off to the right, we would call it skewed right. And then the spread of the data, we can tell if you look at like the space between the minimum and the maximum, we can see that, let's see here, dextromethorphan looks like it is the most concentrated here from, let's see, it looks like about 3 to 13, that's 10 units. And let's see, the honey goes from 3 up to 15, that's more spread out. And then your control here goes from 1 up to, let's see, this is 10, 11, 1 to 12. So definitely honey is the most spread out, we can tell that. So definitely have the most variation in that first one. Although we do have an area of quite a bit of concentration here around 11, 12, 13. Got a lot of the data in there, and then this last one has an area of a lot of concentration too. So those are the kinds of ideas that you want to address when you interpret the data.